This is the Unitree G1. It is capable of running at speeds up to 10 meters per second, navigating uneven terrain, and catching its own balance mid-stride, even after a physical impact. Many Western developers continue to showcase bipedal machines like Tesla's Optimus in controlled laboratory environments. This maintains a widespread perception that physical AI remains in a high-cost research phase, with prototypes expected to retail for over $100,000. That pricing model is being disrupted. The Unitree G1 is already hitting the market with a starting price of just $16,000. While the tech world fixates on software benchmarks and perfect laboratory demos, a parallel industry is manufacturing physical AI at a price point that bypasses the research and development phase entirely. The UBTECH Walker S2 currently operates on the floor of the SI Renewable Energy Factory, executing multi-step logistics tasks and navigating active assembly lines alongside human workers. The system maintains near-continuous operation by autonomously walking to a charging station and swapping its own batteries without any human intervention. Stress testing has moved to the public square. During a recent half-marathon in Beijing, 70 different robotics teams entered humanoid machines to navigate the hazards and unpredictable obstacles of live city streets. This technology is no longer a theoretical concept awaiting commercial viability. It has already clocked in for its first shift. Manufacturing a bipedal robot for the price of a used sedan presents a massive mechanical mystery. Actuators represent the primary cost bottleneck. These mechanical joints typically account for up to 60% of the entire bill of materials. Chinese manufacturers bypass the traditional robotics supply chain, pulling high-torque motors and gears directly from existing electric vehicle powertrains. This strategy leverages a massive, pre-existing industrial base. LiDAR sensors, battery management systems, and CNC machined frames are already scaled to massive proportions due to the nation's dominant electric vehicle industry. Humanoid robots are being treated as bipedal extensions of the EV market, inheriting decades of subsidized manufacturing scale and raw material control. Low-cost hardware is only half the equation. Motors are useless without an AI perception layer capable of complex cognitive reasoning. Chinese city intersections serve as an unfiltered training environment. AI models learn to navigate thousands of mopeds, pedestrians, and vehicles, ignoring standard traffic rules. When placed in these complex 16-way intersections, Western systems like Tesla's full self-driving often hesitate, playing it too timidly for the local flow of traffic. Local AI models adapt to this chaos by threading the needle. They prioritize human-like assertiveness, calculating that stopping entirely in a high-pressure environment can often create more danger than it prevents. Advanced systems like ADS 3.0 track these complex environmental threats in real time, predicting human behavior and adjusting the vehicle's path in as little as 0.1 seconds. Surviving this unstructured environment creates a vastly more adaptable AI than any sterile laboratory simulation could produce. The combination of a $16,000 platform and an AI brain, forged in the world's most chaotic traffic, creates a structural advantage. Government-backed roadmaps call for mass production by 2025, with full integration into hospitals, schools, and homes scheduled for 2027. This gap is difficult to close with software alone. A superior algorithm cannot overcome the structural head start of a localized, high-scale hardware supply chain. Pricing is dictated by geography. Controlling the raw material processing and the manufacturing clusters ensures that the hardware floor remains significantly lower than anywhere else in the world. In a busy urban lot, an autonomous system reverses into a tight parking space and locks itself down, navigating the environment with more confidence than the humans watching it. Success in the physical AI race will be determined by who can master the lowest-cost hardware within the most unpredictable environments. Based on the factory floors and city streets of today, that shift is already occurring.